Hello everyone. First of all, let me give you my introduction. My name is Amit Kumar Agarwal. Total experience is around 12 plus years. I have done my CCI in routing, switching, service provider and data center domain. Here in this video, we are going to discuss about a routing protocol, which is a dynamic routing protocol called RIP. These days, this particular routing protocol is not much in use, but still I am recording this video because you should know what all drawbacks this routing protocol has. Due to that reason, we move to other routing protocols, so it will help you to differentiate the benefits and drawbacks between two routing protocol, and in your career it's easy for you to decide. Let's suppose you get a chance to decide what routing protocol you need to use in your environment, so you can decide it easily. Okay, so first of all, it's a distance vector. Distance vector means it's totally depend upon neighbor. Means this routing protocol, let's suppose we have two routers. In that case, the router which want to send a traffic from one, from destination, from source to destination, it totally depend upon the neighbor. They don't know the complete topology, so that is the first drawback, but this is how distance vector work. Second thing is there is no neighborship required in this, and every 30 seconds it sends the complete routing table, right? So as I have already mentioned that there is no visibility into the network topology, right? So you only depend upon the neighbor. There is no neighbor table, topology table or database table in this routing protocol. It's very simple routing protocol. You just have the database of the learned routes. Yeah. So there are two types of example of RIP, that is RIP version 1 and RIP version 2. I'm not going to explain both, right? So now the RFC number, that is very much important. Yeah, when I start my career, I always go and read the RFC about any technology. So the RFC number of this protocol is 2453. I'm just gonna show you as well how it looks like. And metric is hop count. Means let's suppose from a source to destination, we have two paths, right? And in one path we have only two hops, means two routers in between, and another path we have four routers in between. So it will always choose the lesser hop path. So that is the how it decide the best path between different multiple paths. So it's hop count. So there are a lot of problems with this measurement process, but how it is. If we talk about the load balancing, if let's suppose we have a equal cost path, means we have a 6 path having the same hop count. In that case, the maximum path it can use is 6. Routing updates goes every 30 seconds. RIP version 2 utilize multicast destination address, that is 224.0.0.9. In the upcoming practical, I'll show you where you can see that multicast address as well. So if we talk about the RFC, see, this is the RFC of RIP version 2. You can see when it was wrote, it's 1998, long back, right? And this is the person name, Bay Networks, copyrights and all those. So these are the specific things which, if you are interested, you can go through one by one. So I'm just this is the justification, current RIP, introduction. Here it mention all those things about the introduction, limitation of the protocol. So let's go through the limitations. The protocol is limited to network whose longest path is 15 hops. So that means if you have more than 50 routers, yeah, in your environment, then this protocol will not help you, because it will not work properly under more than 15 routers. Yeah. Now there is the problem depends upon county to infinity problem is there. Okay, this protocol use fixed metric to compare alternative path. There is no flexibility. Means I can explain you this particular point. Let's suppose we have few routers. Router 1, router 2, router 3, router 4, router 5, right? Here is the source, here is the, let me delete this. Let's suppose we have a source server here, we have a destination server here, right? And it is connected this way, R1 to R2, R2 to R3, R4, some switch in between. Let's suppose direct connectivity. I'm just making it for understanding, right? This is R1, this is R2, this is R3, this is R4, this is R5, right? So now the problem here is with this protocol is it will not check the bandwidth of the link, right? It always check the hop count. So let's suppose this is the source, this is the destination, so the hop count is 1, 2, and this path 1, 2, 3. So which one is better? This one. So this way it is finding the best path between, if we have more than one path, but this is not good, right? So that's the one. Then distance vector algorithm, if you are interested, you can learn this algorithm as well. This is also a good algorithm. You can read it down, like how this complete algorithm works. Then we have okay, this one, okay, detailing with changing in topology. So this is also important to go through with this. This is the complete description about this. Split horizon, that is also a good topic. Split horizon means whatever information I am sending to you, you are not going to send back to me. Means what? Means, let's suppose router 1 is giving a route information to router 2. So what split horizon says, that router 2 should not send that packet back to router 1. Why? Because it received that information from router 1 only, right? Otherwise there is a duplicacy of the information. Okay, this is split horizon. Trigger updates, every 30 seconds it sends updates. So somewhere it's written, you can read it down if you want. Protocol specification is there. Okay, message format I'll show you here in this, the Wireshark, just after this. Then we have timers, 30 seconds. You can see every 30 seconds the RIP process is awakened to send an unsolicited response message. Either there is a change in the topology or there is no change in the topology, it always sends an update, right? Input processing, nothing. Request, response, request message and response message. There are two types of messages, you can see here. And trigger updates, that you can learn here. Authentication, you can configure the authentication between two processes. That is also possible now, right? Next up, multicasting. Okay, you can see here it's 224.0.0.9. So the reason why I'm showing you this, because it is not possible in one video to read the complete content and explain you, right? So I show you the path because it's always recommended to go through the RFC, right? If you are a first time learner. Okay, now let's configure RIP routing protocol between three routers. Let's say router 1, router 2 and router 3. Okay, I'll create one loop back between them. Okay, let's take these three routers and then let's first connect the cable, this one and 0 1 to 0 1, right? The subnet between them, I'll take, this is 10.1.1.0/24. Here it is 20.1.1.0/24, right? I'll create one loop back as well. Okay, so that I'll do. R1, R2 and R3. So let's configure the R1 first. Config terminal, no IP domain lookup, line console 0, logging synchronous, interface no shut, IP address 225.0, interface loopback 0, IP address 1. Now show IP interface brief. Very simple configuration. Now let's go to R2. First interface is no IP domain lookup, line console 0, logging synchronous, interface FP0/0, no shut, IP address 10.1.1.2, 255.255.255.0. The second interface is FA0/1, no shut, IP address is 20.1.1.2, 255.255.255.0, and one loopback. Done. Show IP interface brief. All right. Now here, no IP domain lookup, line console 0, login synchronous, interface FA0/1, no shut, IP address 20.1.1.3, then interface loopback 0, IP address, right, done. Okay, now let's enable the Wireshark between R1 and R2. It helps to understand and check the packet between R1 and R2 regarding what I can say, RIP. So now let's enable RIP. So the command is router RIP no auto summary version 2. Auto network I have 10.1.1.0 and my loopback. Done. All right. R2 router RIP version 2, auto summary, network 10.1.1.0, network 20.1.1.0, loopback. Done. Let's go to R3. Router RIP version 2, auto summary, network 0, network. Done. All right. So let's see the Wireshark, if it helps us to see request and response. Okay, so let's remove this packet first. Apply filter not selected. Reply, this one is also apply filter not selected. Okay, so request packet, let's see this request packet. If you see, the first packet is going from where to where? It's going from source 10.1.1.1 to destination is multicast address of RIP 224.0.0.9. so this one is clear. So what is written in the book you can see here. So it's using UDP protocol, so you can see it's UDP 17. This is a multicast address 224.0.0.9 and source is this, destination is this, user data from okay, so UDP port number is 5, protocol number 520. Now routing information protocol, this one, address not specified, metric specified, this one metric 16, that is the request packet. Now response packet, let's open the response packet. See, so in the response, from where to where? Sources, no, this one is again request packet. Okay, response packet 10.1.1.2 sends a response packet, and you can see here what from where 10.1.1.2 sends to multicast. What is sending inside the packet? It is sending that this is the address 20.1.1.0, metric is 1, IP address is this, net mask is this, and the metric is 1. Okay, now let me see if I find something. Okay, between them only, right? So let's stop this. Now go here, go on R1. So how you can check that which routing protocol is configured on routers? The command is show IP protocols. So here you can see routing RIP is running on which interfaces? Fast Ethernet interfaces as well as the loopback interfaces. And then the network which we are advertising through RIP is this network and 10 network. Okay, gateway is 10.1.1.2. And what is the administrative distance of this routing protocol? Is 120. Right. Then show IP route RIP routing table. How you can check the routing table? So now what all route you have? I have 20 network. Hop count is only 1 because R2 is directly providing it to me. I have 2 loopback. Hop count is 1 because R2 is directly providing it to me, and I have 3 loopback. And because 3 loopback is configured on router 3, so it's 2 hop away. Right? So it's a simple. You can say I don't like the metric calculation of RIP, but it is how it is. So we cannot change it. So let's ping. The loopback of 2, it's reachable. The loopback of 3, it's reachable. Right. So if you want to check the configuration, include RIP, let's say. No. Show run grep RIP. No. Show run. Let me show you the running configuration. Here you can see, you will find that. See, so this is router RIP, right? This way. On router 2, let's see. Here everything will be 1 hop away according to me. Show IP route RIP. See, 1 loopback is 1 hop away, 3 loopback is also 1 hop away, and there is no network configuration under routing protocol because it's directly connected, right? So you can reach 1, you can reach 3 as well. Now this is the third one. Show IP route RIP. Okay, ping, ping. Right? The request packet and response packet. So in my upcoming videos I will show you more about split horizon. Yeah, let me see if I can. Yeah. Okay, so in the next video or the upcoming videos I will show you the RIP authentication, more about the request and response packet, right? And filtering, if you want to allow the filtering, that is also possible inside the RIP routing protocol. Okay, so thanks for watching.